talking to you guys about the internals of how vacuum works today. Just as kind of a heads up, this talk is going to be rather in-depth. It was actually, I don't see Simon in here. I actually got the idea to do this talk, seeing Simon do a talk at Vacuum at the last PG Open, and it occurred to me that while there's a number of pieces of information out there about this is how you should tune the different settings and whatnot, I hadn't seen anything that really talked in depth about what vacuum actually does and how it actually works. So that's what I'll be covering here today. I do have, there are some references to actual places in the code in the presenter notes, so if you go ahead and download this, I think we're making the slides available through the website. But if not, I'll have it posted at bluetrouble.com. So today I'll be talking about MVCC, C-log, multi-transactions, some of the machinery that kind of goes into why we have to vacuum. I'll discuss when things can be vacuumed, freezing, hot, vacuum itself, obviously, and then some stuff about Autovacuum. Who knows what MVCC is? Good. Basically, databases, you have two choices to ensure consistent data. You can do locking, which sucks, or you can use multi-version concurrency control. And really what this essentially means is that when you do a delete or you do an update, the old data does not get removed. When you do an update, a new copy of the row is created, and when you do a delete, it's left behind. So that's ultimately the biggest reason that we need vacuum is you have these rows that are left behind that eventually have to be removed. The commit log is what Postgres uses to track whether a transaction has been committed or rolled back or whether it's actually still in progress. Multi-transactions, which how many of you have heard about the recent bugs? Yeah, if you're on 9.3 or 9.4, you need to upgrade because there were some data loss bugs that were found revolving around multi-exacs. But basically, multi-exacs are needed to handle row-level locking and some conditions with update and delete. The reason these two things are related to vacuum is what's responsible for going in and freeing up space in those two storage areas. So, as I mentioned, you're doing updates, you're doing deletes, you're creating these dead rows, but the big question becomes, okay, when you have a dead row, when can you actually go in and remove that? And basically the constraint there is that when you start a transaction or a select statement in Postgres, the database gets what's called a snapshot. And that snapshot has visibility information that determines what rows that individual statement can actually see. So if you have a snapshot in your database that was taken an hour ago, and since that snapshot was taken, you've gone and you've deleted 3 million rows, those rows cannot be cleaned up by vacuum because that hour-old select statement could still need to look at that data. There is the other thing that comes into play here is that if you're using streaming replication, depending on your configuration, streaming replication can have that same visibility impact. Because of the way that streaming rep works, it's a completely binary level replication protocol. So when the master goes and vacuums and removes those old rows. If you had an old select statement on a streaming replica, you now can have this problem where the masters remove the data and the replica still needs it because it's got a query running. So if you have hot standby feedback enabled, your streaming replica will affect the ability for Vacuum to do its job on your master. Prepared transactions, these are different from prepared statements. Basically, the only reason to ever turn prepared transactions on is if you're specifically doing two-phase commit. And the big thing there is that when you prepare a transaction, that transaction has a snapshot that's associated with it. So that prepared transaction, again, will prevent Vacuum from working. Logical decoding can also affect this because, again, while it's not a pure binary replication technology, it's still based on the replay log, and it still has this constraint on Vacuum. So that's kind of the visibility side, but there's other things that affect Vacuum's ability to do its job. Because of how index scans and sequential scans operate, you cannot vacuum a page of data while somebody else is looking at that page. You can't just remove the data out from underneath somebody. So there's a very special lock that has to be acquired at a page level for Vacuum to be able to remove data. These queries can hold these locks. These are not necessarily short-term locks. So especially if you have something like a nested loop scan, the outer side of that loop can potentially hold a pin on a page for a very long time. And that page, while that pin is being held, cannot be vacuumed. What this all boils down to is when you have long-running stuff happening in your database, that prevents Vacuum from being able to do its job. So if you have a very high transaction rate database, you need to then be careful about long-running stuff. And this is also not limited strictly to what table is being vacuumed versus what table is being queried. Because those snapshots, if you get a snapshot that's an hour long and all it's doing is hitting one table, well, the thing is the system has no way to know that that transaction will only hit the one table. So you may be trying to vacuum some other table and it's not going to be, Vacuum won't be able to remove the data.
Is it possible that you have transactions that overlap pinning the same block in a fashion so that Vacuum will never be able to
Yes.
vacuum that?
Yes. And unfortunately, in all the versions up to 9.4, there's no way to get visibility on that. We did add some additional verbose logging. So if you do vacuum verbose in 9.5, it will provide feedback to you when it hits, tries to get the cleanup lock on pages and can't. The one exception to this is a freeze vacuum. Because a freeze vacuum, we must scan and clean every single page. So when Vacuum is freezing, if it can't acquire the cleanup lock, it will sit and wait. And that can actually then cause other problems because while it's sitting and waiting for this cleanup lock, anybody else that needs to get that, to get a pin on that page is going to then sit and wait behind the Vacuum. So, and that's actually the way that Vacuum just used to work, period. I want to say this was changed in like 9.1 or 9.2, where we changed Vacuum so that if it could not immediately acquire the cleanup lock, it wouldn't sit there and wait. Prior to that, it would just sit there and wait, and then any other queries that came along would get stuck behind Vacuum. transaction IDs and multi-X-ACT IDs, multi-transaction IDs, the way that those are implemented is it's basically a circular counter. So it starts at, well, I think it starts at 2 because the first couple values are reserved. But it starts at 2 and it starts increasing. And then when it hits 2 to the 31st, all of a sudden 2 is no longer a transaction that's in the past. It becomes a transaction that's now in the future. So the problem that presents is if you have rows that say, oh, I was created by transaction number 2, and all of a sudden you get to transaction 2 to the 31st plus 2 or whatever, now that row becomes invisible again, because now the database is thinking, oh, this row was actually created by a transaction that's way in the future, and it won't show it to you. So the way that the system works around this and handles this is as the transaction count increases, eventually it has to go through and find all transaction IDs in all tables that are older and replace them with a special value that indicates this row is visible. It's visible to everybody. It will always be visible to everybody until somebody goes and deletes it. That process is known as freezing. And this has to be done both for transaction IDs and for multi-X-ACT IDs. And in fact, if you don't handle freezing correctly, eventually the database will stop allowing you to create new transactions, specifically to prevent this problem of all of a sudden your data starts vanishing. So the key takeaway here is that if you have very high rates of update transactions, you do a lot of for share locking, because for share lock will always generate a multi-transaction, a multi-X-ACT ID. Or if you have a lot of concurrent foreign key checks happening, that's the other thing that tends to generate multi-transaction IDs. If you have very high rates of those, you can run into problems with being able to freeze your data. Heap, sure.
Do you know what's the ID of it? Where's that counter in Postgres?
Oh, how to see what the counter is? It's actually not very easy to see. For a transaction, there's a function, I think it's get current snapshot, something like that. There is a function that you can run that will show you what your current transaction ID is.
TXID current.
Yes.
Your own.
Yes. So you can call TXID current. That will tell you your transaction ID, which is essentially the most recent one normally.
Well, that includes the epoch.
Yes. Yes, so it's not just a raw number. So you have to actually interpret it. But you can interpret it, and then you can compare it to, in PG database, there's a column called DAT frozen XID, and that tells you the oldest non-frozen transaction ID in each database. So you can compare that. There are monitoring scripts out there to do this. I know there's at least one for Nagios. There's probably a few others.
Oh, I was going to say there's a column in PG Clients called Raw Frozen XID.
Yes.
That's the last frozen transaction ID for that table specifically.
It's the oldest non-frozen transaction ID.
Sorry, yes.
Yeah.
Something else, you can also get warnings in your logs that indicate you're coming up on transaction ID wraparound.
Yes.
As well.
Yes.
So as long as you've got processes in place to monitor your logs, you can get a jump on it and know to execute manual vacuums.
Yes. Now, when it comes to multi-X-ACT IDs, I don't know of any way to get that information. I mean, you could write you could write a C function that would expose it, and there has actually been a proposal on the hackers mailing list, and I think it's going to get committed, but probably in 9. Actually, I think it may get into 9.5. That will add a function that will expose the multi-X ID, the multi-X act information. But that, again, right now, there's really essentially no way to do that other than writing a custom C function. Starting in 9.0, we added a new feature called HeapOnlyTuples. So under certain specific conditions, if you update a row, we can actually avoid the need to then come back and vacuum the old row. The way that this works is that if you perform an update and the update does not touch any indexes, it doesn't change any values that are used in any indexes on that table, then we don't need to touch the indexes. We don't need to create a new reference in the index to point at the new row that's being generated by the update. So if you're not touching the indexes and the new row still fits on the same page, you can, the database will do what's called a HeapOnlyTuple, where it does create a second version, but it ties these two together, and they're tied together through the same, basically, address, so that once the old row is no longer visible to anybody, we can do a heap-only cleanup. And that heap-only cleanup is done whenever pages are read. It's a little bit more complex than that, the exact conditions. But this can make a world of difference, especially on tables that have a lot of indexes, because it's those indexes that can really make vacuuming quite expensive. So the takeaway here is that you want to try and avoid referencing heavily updated columns in a table in your indexes. And when I say referencing, that means obviously an index on the column itself, but also if the column shows up in a where clause, or if it's used as a function, if you have a functional index. Where this really comes into play is if you've got a table that you're trying to use as something like a queue table, where you've just got a lot of churn rate that's happening. You don't want to, you want to avoid doing things like putting an index on your status field or something like that, because if you don't do that, your updates to those rows, they become hot, and it makes it a lot easier to keep stuff cleaned up. Vacuum itself. There are 4 major variations on vacuum. Autovacuum is a built-in process that tries to just handle everything and does a pretty good job of it in the most recent versions. Vacuum full completely rebuilds a table from scratch. Vacuum is the regular manually run vacuum. And then vacuum freeze is a special variation on vacuum that essentially it sets some freeze threshold settings to ensure that that vacuum run will freeze everything it possibly can. As I mentioned, Autovacuum, you generally don't have to mess around with it in 9.4. The default settings at this point are pretty good. If you're running older versions, if you're running an old enough version, the one thing that you would probably want to change is originally Autovacuum used a threshold of the percentage of table that had to change that was set to like 40%. So Autovacuum wouldn't try and vacuum a table until there was at least 40% churn, and that's a lot. So if you're running older versions, you would want to change that, but I think that we changed that in like 9.
But it's, for us, we found it's actually, we found the threshold too low, like it would, or it would run too often. As it, I think.
Oh, the current threshold.
It was set to like 0.01 or something like that, so it only like be 1% of the table change when you pick up and run analyze and vacuum.
Yeah, that's
It's really, it's actually.
that's very low.
It's very too low now, and then I'm sorry, the number of rows was set to, I'm sorry, that was set too high, that was set to like 10%. It was set to 50 rows changing. The rows changing is set to 50, which is way too low. So we usually bump it up to like 500 or something like that. But the percentage is actually set pretty well. It's the number of rows changing that we found a bit aggressive.
Got it.
There are other pitfalls with that one. I have one case where batch job was inserting like 1 million rows or so into the table.
Right, they were just going to loop, but.
And
Yeah.
an hour later, a report would run and use these 1 million rows, and it was good if, for example, an analyze was done in between.
Right.
Not a vacuum, but an analyze in that case, and they are the same class of parameters there. And when that million row, because the table grew larger, fell under the threshold, the analyze was not done, and now, because of the index statistics, the optimizer thought, well, that query will return maximum 1 row. Query plan changed slightly and put that one into the inner, into the outer loop, and the query runtime deteriorated slightly, you know? So careful with those parameters.
Right, and if you are in an environment where you do some kind of a data load or you do some large bulk operation, it's a good idea to at least run analyze, if not vacuum as well, depending on what operation you've done immediately after it. Because ultimately Autovacuum generally does a pretty good job, but you can do a lot to give it a leg up, to give it a helping hand by making strategic use of manual vacuums. So one very common case for that is if you've done a bulk operation. Another very common case is if you have something like a queue table that you know gets a lot of churn rate, and especially if you're trying to keep that table small, you want to vacuum that table manually very frequently. I actually typically will go and set up a cron job that vacuums that table once a minute. Because the idea there is if the table is small, that vacuum is very inexpensive. And by vacuuming that aggressively, you're trying to keep it small. If it starts getting big, that's when you start having serious problems. The other thing that you can do with vacuum that can make a big difference is if you have a website that has irregular traffic patterns, or I say website, really any database. If your database has irregular traffic patterns, so say you don't have as much activity during the night or you don't have as much activity on weekends, it's a good idea to go ahead and schedule a manual vacuum to run during those off-peak hours, because the work that the manual vacuum does during that time, Autovacuum doesn't then have to try and do in the middle of the day when everything is busy. One word of caution, something that some people have tried to do is use Autovacuum nap time to try and constrain and control when Autovacuum will actually run. That's a really bad idea. First of all, it doesn't actually work. Some people will be, I only want Autovacuum to run at night, so they set Autovacuum nap time to 24 hours. And maybe that'll work for a while, but then you do a restart, you have some problem and you do a restart in the middle of the day, and oh look, now your 24 hours is occurring in the middle of the day. And there's just other problems that you run into by not running, by Autovacuum not running that frequently.
It seems to me we probably, with the changes we've had to background processes, the ability to set up additional background workers, we may want to put some sort of engine in to help with this kind of stuff. Because in
Right. Yeah, I think the big challenge there is being able to recognize these patterns of, here's a hot spot over here. We need to keep keep a special eye on this. One thing that we certainly could do is that right now, when an Autovacuum worker launches in a database, we don't prioritize the tables in any way, shape, or form. It just says, here's my list of what I need to vacuum, and that's it. So that's something that we could potentially do. So-
Control Autovacuum parameters per sheet.
yes, you can. So you can, but especially in a table that needs to be vacuumed very frequently, it's not very likely to help a lot. Because what happens is vacuum gets tied up vacuuming other stuff, and then it just completely doesn't look at the table.
Oh, I just wanted to say, if you're running a low traffic period cron job to do vacuum, you might want to change some parameters to make it less aggressive.
Yes.
Like,
I'll actually cover that.
vacuum
But yes.
Sure.
Starting in, so prior to 9.0, running a vacuum full was just a completely horrible idea. The way that vacuum full worked is it took the last tuple in the table and tried to move it to the front, and then the second to last and tried to move it to the front. First of all, it did this while holding an exclusive lock on the table, so now nobody can do anything with the table. The other even bigger problem is that in that process of doing it, it was bloating the heck out of the indexes, because each one of these tuples that got moved, it then had to create new index entries, and especially with the way that B-tree works, that could seriously damage, not from a data standpoint, but it could really bloat your indexes. Is anyone running anything older than 9.0? Upgrade, but definitely if you're on 8 something, nobody's on 7. Anyone on 7? Good. Now that I'm publicly humiliating everyone, yeah, if you're prior to 9, just do not even think about running vacuum full. It's really just not a good idea. Since 9.0, what we do instead of that is we just create a brand new copy of the table from scratch. We recreate all the indexes on it. The bad news is this does still require an exclusive lock. So while this is happening, I know nobody can modify the data, and I don't think you can even select from the table. So the good news is you get a really nicely, efficiently packed table, and all your indexes are rebuilt. It's brand new and shiny, but while it's running, you're out of luck for trying to use it. If you do need to, if you are finding the need to actually go do that, there is a project online at GitHub called PG Repack that basically what that does is it does essentially the same thing. It creates the new table, copies all the data over, and builds all the indexes. The difference is this does it a few rows at a time. Or, sorry, it's not a few rows at a time, but it creates the table, but it puts triggers in place so it can remember, oh, hey, here's the stuff I haven't copied, copies the data over, goes in, pulls out the last of whatever got done, and then once this new table is completely in sync, it then takes a very short exclusive lock to swap drop the old table, rename the new one, and then you're up and running again. So if you do need to do this, that's a project that can be very useful.
What's the confidence level on that?
It's awesome. We use it all the time.
Yeah.
Yeah.
What's the name of it again?
Yeah.
Yeah, we've had to use it to get us out of some problems too. I trust it.
Just as a heads up though, PG Repack is a fork from an older project that is now defunct. So you want to make sure you're using PG Repack. I think the other one was called PG Reorg. That's the old one. You want to use Repack.
Can I do a vacuum full on just one partition?
Yes.
Whole table? But there's a lock just for partitions and things.
Yes. No, it locks.
It locks the partitions effectively.
Yeah, it's.
It prevents certain DDL.
I missed what that was.
So the question was, can you, if you're using partitioning, can you vacuum full just a single partition? The answer is yes, because partitioning, really each partition is a standalone table of its own. It's almost essentially just another table. You're likely to run into problems with locking unless your queries are specific enough that the planner can determine that it doesn't need to read from that table. If you're saying, oh, where date is greater than, where date equals today, and you're doing date partitioning and you have the constraints set up and you have constraint exclusion turned on, then the planner may be smart enough to recognize that, oh, hey, I'm just not going to look at the table, but I'm not even sure that that's true. So you still could effectively be.
But the lock is just on the partition.
It is. It is. So if you needed to, you could just manually query some other partition. That would be, yeah. Manual vacuum itself. One thing that might surprise you, you cannot run it in a transaction. It needs to control transaction semantics. So you cannot write a function that's going to manually vacuum. It won't work. There is a vacuum db shell command. If you're doing shell scripting, that can be handy. Likewise, from the cron side. What vacuum actually does is, for each table, it scans the heap, remembering all the tuples that need to be removed. Then it scans through the indexes, removing the tuples from the indexes. Then it removes the tuples from the heap. Finally, if you ask for analyze, it'll do that, and then it'll update the PG database frozen xmin column and the minimum mxid column. The key gotcha here is this part where we scan the heap, remembering a set of tuples, and then we go hit the indexes to remove the tuples, and then go back to the heap. How many tuples can be remembered is controlled by maintenance work mem. If you have maintenance work mem that's set too low, it starts scanning, it then has to stop, do all the indexes, remove those, and then keep scanning again. And those index scans, that's a full scan of every index. So you do not want to set maintenance work mem to some really low level because your vacuum will just die.
Is there a guideline on what relation it has to be to the size of your indexes?
It's not driven by the size of the index. So what we have to remember is a CTID, a tuple identifier, which is 6 bytes. So if you have 1 million dead rows that need to be vacuumed, that's 6 megabytes.
So are there use cases where it makes more sense to drop the indexes first and vacuum and then create them again?
Possibly, but you know,
I actually had a scenario where that was actually true, but there was over 100 million rows in the table. So, I mean, there is a threshold at which it's better to just drop the indexes and build them again later after the process, but it's significantly large.
Gotcha.
yeah. So the vacuum function itself, by the way, I'm now effectively walking through the code. The vacuum function itself calls vacuum rel, vacuum relation. This function vacuums a single table. It does a bunch of mundane stuff that doesn't really matter, and then it calls either cluster relation if it's a vacuum full, or if you've run the cluster command, or it calls lazy vacuum. Before returning, In a regular vacuum that you've just issued the vacuum command, it then calls itself again to vacuum the toast table. There is a difference here though with Autovacuum. Autovacuum considers when a toast table needs to be vacuumed completely separately. It's a totally separate scheduling decision that it makes. So that is one nice thing about Autovacuum is if you're producing a lot of churn in your main table but nothing in your toast table, it's not gonna sit there and keep trying to vacuum the toast table. It'll just leave it alone. Lazy vacuum rel. First thing it does is it figures out, do we need to freeze this table? So it looks at some, there's a couple of configuration settings that control this, and they basically say if the rel frozen XID or the rel min MXID column in PG class, not PG database, in PG class, is old enough and it falls within our vacuum threshold, it then decides, okay, this is going to be a freeze vacuum. What vacuum freeze does, if you say vacuum freeze, it basically sets those limits to 0. So it'll always be a freeze vacuum. It scans the heap using lazy scan heap. Scans the heap and scans the indexes. If it makes sense, if we have removed enough, if we have freed up enough pages at the end of the table, it will try and actually shrink the table on disk. It cleans up the free space map, and finally it'll update PG class with, at a minimum, it will update the row count. It can also, and if it is a freeze vacuum, it'll update those columns as well. Lazy scan heap. This is the function that actually goes through the table page by page by page. When it pulls in a block, it's a little hard to describe this and actually try and make it match the code. But basically, if it's not a freeze vacuum, and there are at least 32 consecutive pages that are marked as being all visible in the visibility map, then it will skip. It will just skip ahead to the next page that is not marked as being all visible. So this can be extremely helpful if you have a table that's, insert mostly. So most of the table, all the rows are visible, and then you just have stuff at the very end that's being updated. Yes. The terms are used somewhat interchangeably in the code, so. And the reason for the 32 block limit there is it wants to try and avoid confusing the read ahead algorithm in the kernel. If we have almost run out of maintenance work memory space to remember tuples, it stops what it's doing, goes and removes all the index tuples from each index. It does the index scans, and then it removes the heap tuples. Next thing, it attempts to get this cleanup lock. If it can't get the cleanup lock and it's not a freeze vacuum, it just says, oh, okay, next block. So that's one, as I said earlier, that's something you have to be careful of is if you're holding, there are certain activities that will prevent vacuuming of blocks within a relation. And honestly, I don't think anybody has any idea if that's a real problem or not. Because as I mentioned, we don't currently track statistics on it. So if it can get the cleanup lock, it calls the page pruning code, which is the same thing that's done for hot cleanup. It's actually this exact same code path. It remembers what tuples are dead. It basically puts a set of TIDs in an array. Or if there is a special case here, if the table has no indexes, it just run pass through the table, and that's it. Is it identifies the dead tuples, it just removes them. But most people have at least one index. So so it remembers the dead tuples, it updates the free space and the visibility map, and then it will do, that's basically the end of the for each block loop. Once it's processed the entire heap relation, it will update statistics, and it does the final pass through the index, hopefully the only pass through the indexes. The index cleanup function, basically, because of the way that indexes work in Postgres, you can actually create a new index method theoretically without modifying any of the Postgres code. What that then turns into is that each index has a different method for how it handles vacuuming. So I don't really want to, I didn't want to try and go into the specific method used for every index. The one thing I will say is that definitely for B-tree indexes, and I'm pretty sure this affects at least some of the other index types as well, if your index gets bloated, it can be extremely hard to actually shrink that index back down because of how B-tree works. So don't let bloat happen. And if it does get bloated, really your best bet is to either do a re-index command, which will lock the table, or you can do a concurrent index build to create a brand new index, and once the new index is built, you can drop the old one. Lazy vacuum heap is the function that actually removes the dead tuples from the table itself. So this gets called after we've called lazy cleanup index on each index in the table. We then call lazy vacuum heap. It goes to each block that it needs to, removes all the tuples that were marked dead, and on each block, on each page, it will defragment the page and record what the free space is. There is a separate function that handles updating the two columns in PG database. That our naming convention makes it very hard to actually say these in English, but dat frozen XID and dat min XID, min MXID. If there are if we have new values for either one, which the only way we can have new values is if vacuum managed to scan every single page in the table. Generally that probably only happens if it was run as a freeze vacuum. But it is smart about it to recognize that if it just so happened that it was a plain vacuum, but it did visit every single page. So now we know that we have the most recent up-to-date information on what the oldest transaction ID and MXID in the table are. It will then still do the update. If that happens, we will update this at the database level, and if we update it at the database level, that is when we call the function to truncate the commit log. It updates the shared memory version of the information, and then the multi-exact files, the cleanup of the multi-exact storage will actually then happen during the next checkpoint. That's it for vacuum. So Autovacuum, there's two parts to Autovacuum. There's the launcher and there's the workers. The launcher prioritizes the databases basically by how close they are to needing to be frozen. First looking at the transaction freeze, second looking at the multi-transact freeze. And if nothing's in danger if nothing needs to be frozen, then it's just going to look at whatever database was least recently auto-vacuumed. Multiple workers can work on the same database at once, and workers will be canceled if they interfere with another backend. So this is another difference between auto-vacuum and manual vacuum. Manual vacuum will never be magically canceled by the system, but if an auto-vacuum worker is doing something and it interferes with another operation in the database, the auto-vacuum backend can be terminated.
What sort of interference are you speaking
DDL, what can actually cause an auto-vacuum worker to be terminated?
For example, when it tries to truncate the end of the heap, that requires some locking, and if somebody else is needing the table, it will do it.
Well, that,
That has changed in 9.5 a little bit, but
well, and in 9.4, the way that works is, first of all, we won't even try and truncate the heap unless we can get the lock without blocking anybody. And then as we're doing the truncation itself, if we detect that we are blocking somebody, we will stop the truncation at that point. And that's true for any.
Well, it's the deadlock detection code that actually kicks in after 1 second of waiting for the lock, and then the process that needs the lock kills the Autovacuum in 9.0.
Yes, that will kill the auto vacuum, but there's actually,
You always have this 1 second pickup in the system.
but there actually is some protection for that for manual vacuum as well.
Why does Autovacuum ignore the Postgres and template databases?
It does not ignore Postgres. So the only databases it ignores is ones that are marked as you cannot connect to them. Because if you cannot connect to them, there shouldn't be anything to do. But it won't actually, unless you set Postgres to be not connect to, it will auto vacuum.
Which is a reason why you should freeze a database before sending it not to connect to.
Yes, yes, that's very important. The workers themselves, they get a list of all the heap tables and materialized views that need to be vacuumed. Then it gets a list of toast tables that need to be vacuumed. It does ignore temp tables, so Autovacuum will never vacuum a temporary table. If you want, if you're doing updates and stuff on a temp table and you think it needs to be vacuumed, you must do that by hand. It makes no distinction on that. For each relation, it attempts to get the lock. If it can't get the lock, it just skips the table entirely. So this is another thing where you have to be careful with, this is another opportunity for long-running stuff in your database to not allow vacuum, or in this case, not allow auto-vacuum to do its work.
Why the temp tables are ignored, actually?
Pardon?
Why the temp tables are ignored?
Well, the biggest reason is because the visibility information for temp tables is handled differently. There's some optimizations that we can do when it's a temp table because we know nobody else is going to read from it. But that then means that vacuum from another process can't, it's not actually possible to vacuum.
It's not just the visibility information. For temporary tables, the buffers themselves are in backend private memory.
Yes,
So
yes.
the backend can't see that at all.
Because we had this issue that somebody was kind of updating temporary table in a long-running session, and they were blocking like hell, so we then kind of recreating them every hundreds of operations. So
You can run a manual vacuum from them, but it does require something like that.
one can run manual vacuum. Okay.
Yes.
You can run a manual vacuum in the session.
Right. And since that session can't be doing anything else in the meantime, you can also just run a vacuum full as well.
Also true.
So it will go through each relation. Once it's run through all the relations, it will call the vac update dat frozen xid function, and then it exits. It does not sit and loop through the tables. Once a worker has run through its entire list of what it identified originally it needed to do, it just exits. Here's a big one. Autovacuum does not prioritize tables within the database. It just says, here's a list of tables that I want to vacuum, and that's it. It doesn't put any kind of priority, and it only runs through the list once. The other big thing with Autovacuum is that it can become ineffective for high demand tables, or if you end up with, so if you have three large tables, the default configuration is you have 3 Autovacuum workers. If you end up with 3 large tables that all show up on the list and all need to be vacuumed at once, all 3 workers are going to be stuck doing that, and nothing else is going to get vacuumed until one of those workers frees up. So these are some of the things that factor into why, especially for tables that you're trying to keep small that have the high churn rate, you still want to vacuum those by hand. Vacuum cost delay, it's pretty well documented. Really the critical thing is that as certain operations happen in vacuum, either reading a page out of shared buffers, reading it from the kernel, or dirtying the page, each one of those has a cost associated with it. We keep a running total of the cost, and when the cost exceeds the auto or vacuum cost limit, we then sleep for some number of milliseconds. The entire idea here is to prevent vacuum from just sucking down every last available piece of I/O that you've got. One thing you need to be careful with is don't slow vacuum down too much. So don't set some huge cost delay, or don't set the cost limit really small, because if you do that, yes, you're going to save on your I/O bandwidth initially by throttling the heck out of vacuum, but it then means vacuum's not getting the work done that it needs to get done. And that means that your table is just going to end up, over time, it's just going to get more and more bloated. You're actually making things worse. So don't do that. The other trick here is that if you have systems with nice, expensive RAID controllers, with nice RAID setups, a lot of time it is actually cheaper to write data than it is to read data. So if you have a nice, expensive RAID controller, you may want to set the page dirty, vacuum page dirty parameter lower than the page miss parameter, because it's cheaper to write the data than to go to the kernel to get. So basically, just to reiterate the key points, long-running transactions, they mess with vacuum. High transaction rates, use of for share lock, and lots of concurrent foreign key checks increase the need to freeze because they burn through MX IDs. Indexes referencing heavily updated columns, they prevent hot from working, which creates more need for vacuuming. Make sure maintenance work memory is large enough. It's very difficult to reduce the size of a bloated database, and Autovacuum can only do so much. It's not magic, as much as we might wish that it was. I am out of time, but I'm happy to stick around for questions. I think it's lunchtime at this point. Thank you.